Okay, welcome to the Aspire Academy. Myself Siddharth. So, in our last class, we have discussed about what electric charges and electric field. So now in this we have already discussed what is charge, what is charge, what is the properties of charge, what is the basic properties of charge, like that. What is electrostatic induction? Now we are going to start about a new concept. It's called electrostatic induction. So what is called electrostatic induction? First, suppose it is a one kind of temporary electrification of a conductor. Is one side is completely positively charges and another side is completely negatively charged. This process is called electrostatic induction. So how we can do this electrostatic induction? Suppose say one kind of this is a conductor. Suppose this is a conductor. So this is a conductor. So what is this? It's a conductor. Conductor has what? This is a conductor and this is a one kind of insulating stand. It is an insulating stand. So this is a conductor and this is a insulating stand. So what happened? The conductor means what? It's a what? Free electrons are. Positive and negative charges are associated with it. So it is a free electrons are there. So what are the free electrons? So positive, negative charges are here accumulated and distributed and dissipated here. So positive, negative charges are there. So this is a what? One kind of conductor. Suppose if we brought one positively charged glass rod here. So if it is brought one positively charged glass rod. So this is called glass rod. So this is a positively charged glass rod. Then what will happen? What will happen? In this case, after due to the attraction and repulsion, what will happen? What will happen? Here, due to the attraction, here negative charge is accumulated here, and here positive charge is accumulated here in this conductor. So it is a temporary process where if we remove this positively charged glass rod, then automatically there all the charges are dissipated. So this process is called electrostatic induction. Okay, so electrostatic is one kind of phenomenon where is a temporary phenomenon where one side all the electrons and protons or positive and negative charge are temporarily separated from at one side and another side. So this is called electrostatic induction. So next topic, we have already discussed the Coulomb's law in vector form and Coulomb's law in vector form and dielectric constant, all the things we have discussed in our last classes. So now here we have now discussed about what is electric field now. First of all, what is electric field? What is electric field? This is an important thing. Electric field is denoted by capital letter E. So what is electric field? First of all, so suppose if a positive charge is here, suppose it is a positive charge is placed here. So this is a positive Q charge is placed here. So here how we know that is a positive charge is placed here. So similarly another positive charge we bring here, another positive charge, suppose this is called Q naught charge is bring here. So what happened? Due to these are two the positive charge, then what will happen? They can repel each other. So the force will develop in this direction. So force will develop in this direction. Okay, so this is a distance here and this is called source charge and this one is called test charge. So this Q charge, source charge, another positive charge, Q charge is positive charge and Q naught another test charge which is also positive charge and brought near it. What will happen? The force will develop. So what will happen? What is the meaning of that force will happen? Suppose a positive charge here and another positive Q naught charge positive here, and again in particular from this point they can repel each other. So here this is a region where electric influences are occur. Okay, so in this field, so here force is developed. This force is called what? Repulsive force, and the electric field is generated in this sense. So the electric field we can also define as now in this way that electric field is equal to what? this electric field is equal to E is equal to F by Q naught. So E is equal to what? Now after this conclusion, we can conclude here E is equal to F by Q naught. F by Q naught. So this is the general formula for electric field. So now what is electric field? We already calculated. Electric field or field strength, same thing. Electric field and field strength are same thing. So now what is the SI unit of E? What is the SI unit of E is equal to what? We know E is equal to what? F by Q naught. So what is the unit of F? Force. Force means what is F? F means here force. Force. Q means what? Charge. This is charge. So force or SI unit is a Newton, and Q C charge is called Coulomb. So after that, Newton per Coulomb is the SI unit of electric field. So now we are discuss what is electric field. Now after that, electric field is a basic formula for electric field is what? E is equal to F by Q naught. And what is the SI unit of electric field? Newton per Coulomb. So in this way we can define the electric field. So now in now we know that what is electric field. Now in our electric field we can calculate in various way. So electric field in a suppose in a axial point, electric field in a suppose equilateral point, electric field is a any point, and these are the something. So first of all, main formula for electric field is like that. E is equal to F by Q naught. So after that, another one is there, another topic is what? Electric field due to a point charge. Next topic is what? Electric field due to a point charge. How we can calculate the electric field in any point charge? So suppose next topic, electric field due to a point charge. It's a very important topic for your exam point of view. And this is first of all we know that what a general formula for electric field is equal to what? E is equal to F by Q naught. Now the another formula, this is a different formula. So this is called what? Electric field due to a point charge. So how we can define? Suppose similarly the one diagram, suppose this is a charge, this is called Q charge. This charge is called, we know, the source charge. Source charge. Okay. Another one, suppose a point here, we can place a point. This is point P. This point we can place another charge. Suppose Q naught charge is placed here. With a distance how much? R distance. We can place the charge is called Q naught. What will happen? These are positive charge. Both are positive charge. Then what will happen? The force, repulsive force will be developed. This force, repulsive force will be developed. In this point P, we have to calculate what? Electric field. So how we can calculate the electric field? So we know that here two charges is placed. What are the two charges? One charge is called Q and another charge is called Q naught, and with a separation of R. So which formula we have to calculate the force? Obviously the Coulomb's law. So according to the Coulomb's law now, according to the Coulomb's law, so what is the force here? We know the Coulomb's law force is equal to what? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the Coulomb's law. We have already discussed in the last class. So according to Coulomb's law, also we can apply this formula here. So F is equal to what? Here same thing, 1 by 4 pi epsilon naught. Q1 means what? Here Q. Another Q2 means what? Q naught. What is the distance? R square. So this is the force developed in these two charges. Now our aim is to what? Our aim is to calculate the electric field. So how we can calculate the electric field? We know the basic formula is equal to E is equal to F by Q naught. Okay, so now our aim is to calculate what? Electric field. So electric field is equal to E is equal to what? F by Q naught. Already know we E is equal to F by Q naught. Now what is F? We are calculating the F. F is equal to what? 1 by 4 pi epsilon naught q naught by what? R square, then q naught here. So this q naught and this q naught is cancelled. Now after that what will happen? After that 1 by 4 pi epsilon naught q by r square. So now we are getting that electric field formula is equal to what? 1 by 4 pi epsilon naught q by r square. So this is the another formula for electric field in a point charge. This is very, very important. So now this formula is not used in every aspect. Now this is the main formula where we can use the electric field. Okay. So this is the all about what? Electric field due to a point charge. Any confusion? So after that, so this is the electric field due to a point charge. Okay. So now another one topic. This is called dipole. What is called dipole now? What is called dipole? Next another one. This is called dipole. So what is dipole here? So first of all, what is dipole? Di means what? Two. Pole means what? Two poles. Dipole means two poles. So what is the two poles? Two pole means the polar constants are the what? Charges. So what is the definition of dipole? Electric dipole. So definition of electric dipole is what? Two equal and opposite charges separated by very small distance is called electric dipole. So what is the definition? Two equal and opposite charges separated by a small distance is called electric dipole. Two equal and opposite charges separated by a very small distance is called electric dipole. So now two equal and opposite charges. So one positive negative charge here and equal and opposite. Another one is called positive charge separated by very small distance. So we can consider twice is the very small distance here. So this is the diagram for electric dipole. So two equal and opposite means one is positive and another is negative. This negative and positive and distance between them is twice a. So small distances we can consider as twice a. So Q and Q. So here, so this is the diagrammatic representation of what? Electric dipole. Another one term is called dipole moment. Dipole moment. Dipole moment we can represent as small letter p. So small dipole means what? What is dipole moment? Strength of this electric dipole is called strength of the electric dipole. Strength of the electric dipole is called dipole moment. Is called small letter p. So strength of this electric dipole is called a dipole moment. So dipole moment here, this is a p, is dipole moment always directed towards negative to positive. So dipole moment is always directed towards negative to positive. So what is the dipole moment formula? Dipole moment is equal p is equal to q into twice a. Product of charge into distance between the two dipole, one dipole is called dipole moments. So dipole moment is formula is called what? Q into twice a. So its direction is called, what is the direction of the dipole moment? Direction is called always negative to positive direction. Negative to positive direction. So this is very, very important for your exam point of view. First of all, we have to know what is dipole. Dipole means two equal and opposite charges is separated by very small distance is called dipole Very small distance called dipole. So dipole moment is the what? This dipole has some strength. So this strength is called dipole moment. So we know that. So this is the diagrammatic representation of what? Electric dipole, and this is the P is we can represent as dipole moment. So dipole moment is what? Strength of this dipole is called dipole moment, and this is denoted by in a mathematical way as P is equal to Q into twice is the what? P is equal to Q into twice is the what? Dipole. P into Q into twice is the dipole. So dipole moment. So P is equal to Q into twice a dipole moment. So what is the SI unit of dipole moment? SI unit is what? SI unit P is equal to Q into twice a means what? P is equal to Q into twice a. Q means what? Coulomb. What is the SI unit of charge? Coulomb, and twice a means the distance meter. So Coulomb meter is the SI unit of what? Dipole moment. So this is all about the dipole and dipole moment. So see, there is any confusion? So ask me. So this is the main thing. So it is a dipole moment and electric dipole. This is a very simple conception, and also you have to know what is the direction of electric dipole. Direction of electric dipole is always directed towards negative to positive. Negative charge to positive charge is the direction of electric dipole moment. Okay. Okay then. So next one. So next, so one numerical, what is the dipole moment is one numerical we have given. So first of all, dipole moment. First of all, one question is there arising here. So this question is like that. An electron question, an electron is separated from proton through a distance of 0.53 angstrom. Calculate the electric field. Calculate the electric field at the location of the electron of the electric field, or electric at the location of the electron, So this is another question regarding an electron is separated from a proton through a distance of 0.53 angstrom. So given what distance we can call as r, what? 0.53 angstrom. So we know what is 1 angstrom means what? 1 angstrom means what? 10 to the power minus 10 meter. So now we have to place it here, 0.53 into 10 to the power minus 10 meter. So distance, all are we have to standard unit. So we have to calculate what? Location of the electron. So we have to calculate what? E, we have to calculate E. So we know what is the formula for electric field. E, electric field, or formula is equal to what? Electric field, we have to calculate electric field. So E is equal to what? F by Q naught. So electron is separated from a proton. The electron is separated from a proton means one is positive charge and another negative charge. So what is the force formula? We know force is equal to what? 1 by 4 pi epsilon naught Q1 Q2 by R square. So here Q1 is equal to what? Q1 is equal to 1.6 into 10 to the power minus 19 Coulomb, and Q2 suppose electron, so minus 1.6 into 10 to the power minus 19 Coulomb, because 2 electron and proton means this is Q1 and this is Q2. Okay, so here how you can represent this Q1 Q2? So So E is equal to F by Q naught, or we can also recreate E is equal to what? E is equal to, we know, the F 1 by 4 pi epsilon naught Q by R square. Now we have to know that we cannot do these things because this is a very lengthy process, but we know the electric field. In this process also we can calculate, but this is a very lengthy process, so that's why we are using E is equal to what? 1 by 4 pi epsilon naught Q by R square. So 1 by 4 pi epsilon is 9 into 10 to the power 9 into what? Q is charge. We can consider any charge, 10 to the power minus 19 divided by 1, 0.53 into 10 to the power minus 10 whole square. So after that, after calculation, we are getting what? After calculation, we are getting 5.1. We can do it, 5.1 into 10 to the power 11 Newton per Coulomb. So this is the answer for this question. So any confusion? First of all, an electron is separated from a proton through a distance of 0.53 angstrom and is calculate the electric field at the location of the electron. So first of all, we know what is R, 0.53 angstrom, and 0.53 into 10 to the power minus 10, because 1 angstrom is equal to what? 10 to the power minus 3, sorry, 10 to the power minus 10 meter. So after electric field, we know electric field is equal to F by Q naught, but this formula we cannot use here because this is a lengthy one. So first, in this equation, force is there. So if for force, we can calculate what? 1 by 4 pi epsilon Q1 Q2 by R square. So that's why it's a very lengthy process. So that's why this is another equation we are getting in this class. So 1 by 4 pi epsilon naught Q by R square. So after placing this the value, we are getting what? What is the formula? What is the answer? 5.1 into 10 to the power 11 Newton per Coulomb. Okay, this is a very important question. So next one, electric dipole, we can avoid this one. Suppose electric dipole and electric dipole moment we have already discussed. So another one topic, electric field at an axial point of a dipole. Electric field at an axial point of a dipole. How can we proceed this one? So electric field at an axial point of a dipole. Suppose in this dipole, suppose this is dipole we can consider. So this is a dipole. Which one? This is minus Q. This is plus Q. What is this? This is separated by what? Twice a distance. Okay. Axial point means, suppose this is an axial point. Suppose here we can consider a point. This point is called axial point. In this point, we have to calculate what? Electric field. So electric field at an axial point of a dipole. Here this is dipole, minus Q plus Q, and this is a what? In this P point, we have to calculate what? Electric field. Then how we can proceed first? So we know this is going center of this dipole, and this distance is going considered as A, and this is another distance, suppose A. From the center O, and this point is called, we can consider as distance is equal to R. This is another distance. This is distance is called R. So how can we proceed this one? So first of all, for the minus Q charge, what is the electric field at a point P? And for the plus Q charge, what is the electric field at a point P? So first of all, so next, electric field, now we have to calculate electric field due to a charge minus Q, due to a charge minus Q at a point P is, at a point P is, what is the electric field at a point due to the minus Q charge? We know electric field, we have to already calculate 1 by 4 pi epsilon naught what? Q by R square. So here E minus Q, electric field, for which charge? Minus Q. 1 by 4 pi epsilon naught what? Q is equal to what? Minus Q by R square means what? From here to here distance. So this is a R, this is a A, so R plus A whole square. Is it? Any confusion? So why it is R plus A? Because this is a dipole from this point to that point. What is the electric field? So you will calculate the distance R, because electric field, this formula is equal to what? 1 by 4 pi epsilon naught Q by R square. R is the distance from here to here now. So sorry, R from distance to here. So R from here to here distance we can calculate, but we know the distance between here to here. Here means this point P to point O. Suppose we can consider this a point O. Distance is suppose R. So R plus A is the distance between the minus Q to point P. Next, again, electric field due to a charge plus Q at a point P is what? So E plus Q is equal to what? 1 by 4 pi epsilon naught plus Q by what? From here to here. Now earlier the distance will be from that one to that one. Now distance will be what? From here to here. So from here to here plus Q to P is equal to what is the distance? What is the distance? This is R, this is minus, this minus, so R minus A. R minus A whole square. This is equation number 2. Any confusion? So electric field due to a point minus Q charge. So this is the what? E minus Q. E minus Q. So U minus Q. E minus Q 1 by 4 pi epsilon naught minus Q by R plus A whole square. E plus Q for the charge, the plus Q charge 1 by 4 pi epsilon naught what? Plus Q by R minus A whole square. So what is the total electric field now? So what is the total electric field? Total electric field is equal to how much? Total electric field is equal to how much? Total electric field is equal to what? E plus Q plus E minus Q. Both the electric charge field we have to add it, then we can get the total electric field. Now we are doing this one here. Okay. Now total electric field E is equal to how much here? For we can common it 1 by forward this one 1 by 4 pi epsilon naught Q by R minus A whole square plus 1 by 4 pi epsilon naught minus Q by R plus A whole square. So this minus plus minus 1 by 4 pi epsilon naught common, we can take Q by 4 pi epsilon we can common, Q by 4 pi epsilon naught we can common. So 1 by R minus A whole square minus 1 by R plus A whole square. So after that Q by 4 pi epsilon naught we can get what? R minus A whole square and R plus A whole square LCM is how much? R plus A and R minus A whole square means R square minus A square whole square is the what? LCM. So R plus A whole square minus R minus A whole square. So this is the thing, up to that thing. Then again, now we can erase these things. First of all, what we get? So after that, electric field is equal to how much? Q by 4 pi epsilon naught. R plus A means R square plus twice AR plus A square. This minus, so what? R square minus twice AR plus A square divided by what? R square minus A square whole square. So after that Q by 4 pi epsilon naught, this is only calculation, R square minus A square whole square, then R square plus twice AR plus a square minus r square minus minus plus twice ar minus plus minus a square. So this a square cancel, r square cancel. After that we are getting what? After that we are getting q by 4 pi epsilon naught r square minus a square whole square, then 4ar. We know 4ar, but we know that dipole moment is equal to p is equal to what? Q into twice a. Q into twice a. Now we can proceed like that. 1 by 4 pi epsilon naught q into twice a into twice r. Can you write like that? R square minus a square whole square. Then E is equal to what? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. This we can call as P. This we can call as P, dipole moment. So 2pr divided by r square minus a square whole square. So this is the electric field due to a point charge, axial point. Okay. So this is the another point. So electric field is equal to 1 by 4 pi epsilon naught 2pr by r square minus a square. P is called dipole moment. R is the distance between the what? Distance between the midpoint of a dipole to that where we can calculate the pole. Electric field. So this is the formula. We are getting what? These are very important formula for your numericals. If a point is lies in an axial point, so what is the electric field? We can only axial, because electric field is axial point. 1 by 4 pi epsilon naught 2pr by r square minus a square whole square. This is very important point, axial point. Okay. Now another special case. Special case is like that. If r is very greater than a, then what will happen? If r is very greater than a, then a square can be neglected. Can a square can be neglected? So what is the axial now? Axial, the 1 by 4 pi epsilon naught. The a square is neglected means was 2pr divided by r square. R square is r to the 4. This one cancel, cube, and E axial is equal to what? 1 by 4 pi epsilon naught twice p by r cube. This is another special condition for what? This is another special condition for what? E axial is equal to 1 by 4 pi epsilon naught 2p by r cube. When it will be valid? Then whenever r is very greater than a. When r is very greater than a, then we can neglect the a square term. So in this case 1 by 4 pi epsilon naught 2p by r cube is the what? Electric field due to an axial point of a dipole. Okay. So this is an important thing. So another one. Another important topic is what? Electric field at an equatorial point of a dipole. This is very important. Electric field at an equatorial point of a dipole. Electric field at an equatorial point of a dipole. So before starting this, first of all we know that another concept is called electric field lines. What is electric field lines? So what is electric field? What is electric field lines? So what is electric field lines? First of all, so these are imaginary lines. We can consider, suppose if a positive charge or negative charge we can place in a space, so we are considering some imaginary line which is called, these are electric lines of force or electric field lines. So some properties are there in electric field lines. So suppose it's a positive charge, this is a positive charge, all the electric field lines are coming out from the field. Okay, another one, if it is a negative charge, all the lines are enter here. Now these are the two properties of electric lines of force, so electric field lines. So first of all, we have discussed, in exam it may be asked that write the properties of electric field lines. Okay, so this is a very, very important topic. So these are, next is called properties. So what are the main properties? First of all, which one are the main properties of electric field lines? So first property is called electric field lines is a continuous curve. First of all, the field lines are continuous curve. This is a continuous curve. Okay. Next point is what? The field lines, the lines of force start at what? Positive charge and at negative charge. This line also we can written like that. The electric field lines from the positive signs, all the electrons lines of force are begin, and in negative charge all the electrons lines of force are what? Entering in the negative charge. So these are the things. And after that, third point is what called two lines of force cannot intersect each other. This is a very, very important point. The two lines of force cannot intersect each other. The lines of force cannot intersect each other means, suppose it is a positive lines of force, suppose it is a positive line, another one negative charge, it cannot intersect each other. It cannot intersect. Why it is cannot intersect? Because now fourth point, the tangent of the fourth point is what like that. The fourth point is the tangent to a line of force at any point gives the direction of the electric field lines at that point. So what is the meaning of? These are the four important properties of electric field lines. So first one, the field lines are continuous curve. Okay, the field lines are continuous curve. The field lines of the start at positive and at a negative charge. We have already discussed. Two lines of force cannot intersect because the tangent of the electric line force of force. Suppose an electric lines of suppose is a positive charge, the lines of force are like that. So suppose we can consider that 3 points are considered. This is point A, this is point B, and this is point suppose C. So what is the direction of ABC? Now how we can calculate the direction of ABC? Now we can give one tangent here. This is one tangent here. So this is the tangent support. This is the direction of electric field EA. This is the electric field point BEB, and this is the EC. So electric lines of force has direction. How? The tangent of that lines, that point is called the direction of the electric lines of force. Now the third point is what? The two lines of force cannot intersect each other. When two lines of force cannot intersect each other, suppose this one is positive charge. Suppose this is positive charge, here we can get, and this is negative charge here. Is it possible? No. Suppose while it is intersect, in one point two direction is not possible and two values will be not possible in a intersect point. That's why electric lines of force cannot intersect each other. Okay, this is the main thing, and this is electric. And today we have discussed about what? First of all, electrostatic induction, and what we are discussing, what? Electric dipole. What is electric dipole? What is electric dipole moment? What is the direction of electric dipole moment? And another one, another one is what? What is the electric dipole at the axial point? What is the axial point? And what is the electric field? What is electric field? What is the value of electric field? There are two general formula. One is called E is equal to F by Q naught, and another E is equal to 1 by 4 pi epsilon naught Q by R square. From that one, what is dipole moment? And another one is what? Or electric dipole. What is the electric field at a dipole of the in axial point? And another one is the electric field lines. So thank you.